Right, so number 1. It says evaluate the indicated function, and it gives us f and g, and we have to subtract them. Subtract them and plug in 4t. So the 4t is just a value, a term that we are plugging into all the x's. So we can do it either by subtracting them first and then plugging in 4t at the end, or plug in 4t to each and then subtract them. I'm going to subtract them first. So it's f minus g. So we have x squared plus 2 minus g. Be careful when you have more than one term in the second when you subtract, because we're going to have to distribute. So this would be x squared plus 2 minus x plus 3. Then we combine our like terms. So x squared minus x plus 5. And now it asks me to plug in 4t into my x's. So I have 4t squared minus 4t plus 5. 4t squared, we have to be sure that we distribute that squared to the 4 and the t. So it would be 16t squared minus 4t plus 5. And that's our answer. All right, for number 2, we have to find the composition function, so f of g, and state the domain of the composite function. So when it's written like this, it could also be written like f of g of x, so these mean the same thing. The second one is what goes on the inside. So I take the g of x and plug it inside the x and the f of x. So this would be the square root of x to the 5th power plus 2. Now to find the domain, there's a couple things we have to check for. When it's a composite function, we always have to check the domain of the inside and the domain of the whole thing. So my domain for g of x, do I have anything that x can't be when it's x to the 5th power? No. So it would be all real numbers, negative infinity to infinity. That's just for the g. X, like we have restrictions on the x when it's a square root, because what can x not be when it's inside a square root? Negative. So we would set x greater than 0 to find, or whatever's inside, we set it greater than 0, greater than or equal to, because it could be 0. And then we also have a restriction when x is in the denominator of a fraction. It can't be 0, so we would say x is not 0. Or whatever's in the denominator is not 0. Sometimes there's more than one thing in the denominator. We would just solve for x. So now for my domain of the whole thing, my f of g of x domain, I have a restriction here because I have a square root. So I set what's inside the square root greater than or equal to 0, because it can't be less than 0. So I have x to the 5th power plus 2 is greater than or equal to 0. We solve for x. So how would I solve for x here? Move the 2, so subtract 2. X to the 5th power is greater than or equal to negative 2. And then to get rid of that 5th power, I would take the 5th root of both sides. So x is greater than or equal to the 5th root of negative 2. So for our domain of the whole thing, it has to be what overlaps. So because this is everything, and this is specific, we would say the domain is x is greater than or equal to the 5th root of negative 2. It could be written like this, or it could be written in interval notation, so it would be the 5th root of negative 2 to infinity, because x has to be greater than it. And this would be a bracket, because it's x is greater than or equal to. So these are the same, just written 2 different ways. Number 3 says find the inverse algebraically. What would I need to do to find the inverse? Flip the x and y. So I can make the f a y, because f of x is just a fancy way of saying y. And I'm going to flip the x and y. So I'm going to say x is equal to the square root of 2y plus 6. Now I'm going to solve for y to find the inverse. I need it to be y is equal to. So I got to get that y all by itself. I'm going to subtract 6 on both sides. So x minus 6 is equal to the square root of 2y. How do I get rid of that square root? Square both sides so it cancels out. Now be careful because I'm squaring the whole left side, so that's why I put it in parentheses. So I have x minus 6 squared is equal to 2y. And then what should I do next? Divide by 2. So I can say the inverse is equal to x minus 6 squared over 2. Well, you can't distribute the squared. You would have to write it twice and FOIL it. So I would just say leave it like this. No need to FOIL it out. If you FOILed it out, it wouldn't be wrong, but you don't need to. Yeah, you could have also written as f of x to the power of negative 1. Just saying the inverse of that. Right, number 4. Algebraically, we have to determine if the function is even, odd, or neither. How do I determine if something's even, odd, or neither? We plug in a number and its opposite, and we see if we end up with the same answer, different answers, or opposite answers. So I'm taking the cubed root of something. What's like a nice whole number I could take the cubed root of? 8. So what can I plug into t to make this 8? 14. So let's plug in 14. So I'm going to plug in g of 14. And I have to plug in its opposite too, so negative 14. Usually we would plug in like 2 and negative 2, just because they're going to be nice, easy numbers to plug in. But here, since we have the cubed root, you can plug in whatever number you want and its opposite. So if we pick positive 14, we have to do negative 14 also. So here I have the cubed root of 14 minus 6. So the cubed root of 8, which would be 2. So we get 2. Now let's plug in negative 14. So the cubed root of negative 14 minus 6, the cubed root of negative 20, is the cubed root of negative 20 and 2 the same thing? No, these are different. So that means our answer would be neither. If you get the same answer, that means that it is even. If you get opposite answers, that means that it is odd. And if you get different answers, that means that it is neither. Any questions here? Number 5 is another inverse question. So we just flip the x and y. So I can say x is equal to y to the 7th power minus 6. And we solve for y. How would I solve for y? Add 6 to both sides. So x plus 6 is equal to y to the 7th power. What should I do next? Take the 7th root of both sides to cancel out with the 7th power. So I get y, my inverse of y, is equal to the 7th root of x plus 6. Which again, you could say the inverse of y, or you could say the inverse of f of x. Same thing. Right, number 6, we have to find the domain. So we said we have to be careful and look for if x is in the denominator and if x is inside a square root. Do I have x in the denominator? Yes. So if it's in the denominator, we have to say the denominator is not equal to 0. And we solve for x. So here I would subtract 1. So x squared cannot equal negative 1. Take the square root of both sides. Can I take the square root of negative 1? No. So will x squared plus 1 ever be a negative number? No. So what do you think my domain is here? Will x squared plus 1 ever be 0? No. So do I have any restrictions on my domain? So my answer is negative infinity to infinity. Because this is imaginary, if it was an actual number, then that would be included in our restriction. But this isn't a real number, it's imaginary. So we have no restriction on the domain, because I could plug in whatever number I want into that x in the denominator, and I will never get 0. So because this is imaginary, it's all real numbers, negative infinity to infinity. I can plug in whatever I want. So let's just say we had x cannot equal 1. So I would write that as negative infinity to 1, and then 1 to infinity. Because it could be all the negative numbers before 1 also, although the number is smaller than 1. Right, it's a parentheses here because 1's not included. Like, if it asks for interval notation, that would be this one. But if it's multiple choice, it could be written either way. All right, let's look at B. So I also have to be careful when I have a square root, because what type of number can I not have under a square root? Negative. So I would have to say what's under my square root is greater than or equal to 0, because it can be 0. It just can't be less than 0. So I would say x squared minus 16 is greater than or equal to 0. Solve for x, so we add 16 to both sides. So x squared is greater than or equal to 16. Take the square root. So what is x greater than or equal to? Just 4? Plus or minus 4. Anytime you take the square root of both sides, you need the plus or minus. So x is greater than or equal to plus or minus 4. This is technically two numbers here. So I need to figure out what type of numbers I'm talking about. So I'm going to put them on a number line. So either outside of these numbers is going to be true, or inside of these two numbers are going to be true. So I can plug in a number just to test and see if it works. So I'm plugging in a number inside here. So I have x squared minus 16 is greater than or equal to 0. We need to test a number to see if it works. So let's test something smaller than negative 4. So negative 5. So negative 5 squared minus 16 is greater than or equal to 0. 25 minus 16 is greater than or equal to 0. So this would be 9. Is 9 greater than or equal to 0? Yes. So outside works. Let's test a number inside. So in between the numbers, we have 0. So 0 squared minus 16 is greater than 0. Is negative 16 greater than or equal to 0? No. So that's not true. So in between doesn't work. And then let's test a number that is outside again, but just greater than 4. So we can test 5. So 5 squared minus 16 is greater than or equal to 0. So again, I have 9 is greater than or equal to 0. Is this true? Yes, so outside here works also. So now I want to write this in interval notation for my domain. How could I write this? Perfect. Awesome. I can include -4 and 4 because I have that equal to, so that's why those two numbers get the brackets. It just can't be anything in between -4 and 4. All right, let's look at number 7. So we have to determine whether the lines passing through the points are parallel, perpendicular, or neither. So here, to find out if they're parallel, perpendicular, or neither, we have to find the slopes of the lines. If they are the same slope, that means that they're parallel. If they are opposite reciprocals, that means that they're perpendicular. And if they are totally different numbers, then it would be neither. y2 minus y1 over x2 minus x1, our slope formula. So for the first line, I have x1, y1, x2, y2. Let's plug them in. So 0 minus -4 over 7 minus 2. So we get 4 over 5. That's the slope for my first line. We're going to do the same thing with the second line. So I have x1, y1, x2, y2. So 0 minus -8 over 4 minus 14. So this would be 8 over -10. So 4 over -5. Are these slopes the same? Are they opposite reciprocals? No. So what do we know about these two lines? They are neither. So they're not parallel nor perpendicular. So they have to be opposite reciprocals, meaning one has to be positive, the other one has to be negative, and reciprocal means that it's the flip. Yeah. So if the second one was -5 over 4, then they would have been opposite reciprocals. But they are not here. For 8, to determine the x-intercepts, we make y 0, and then we solve. So here I'm going to have to factor, but what should I do first? Take out the GCF. So I'm going to divide everything by 2. When your GCF is just a number, you can get rid of it because it divides, 0 divided by 2 is just 0 still. So I have x squared minus 2x minus 8. Now we can factor. What are two factors of -8 that add to -2? -4 and 2. So this would be x minus 4 and x plus 2 equals 0. So x is equal to 4 and x is equal to -2 because we would just set both of them equal to 0. But to write my answer as x-intercepts, it would have to be 4, 0 and -2, 0. Number 9 says find the zeros and state the multiplicity. So to find the zeros is the same thing as factoring or solving. Just a different way of saying it. So I would make my g of x 0. What can I do to solve for x here? I can group them. Anytime you have 4 terms, you always want to check and see if you can group them. So group the first two, group the second. What's my GCF in the first group? X squared. So I'm going to take out an x squared, and I'd be left with x minus 5. What's my GCF in the second group? -4. So I take out a negative 4, and I'm left with x minus 5. Perfect, because the inside parts have to be the same. The inside parts go into one group, so x minus 5. And then the two outside parts go together in the second group, so x squared minus 4. Now this is still equal to 0, so we still have to solve it. I can set each piece equal to 0, so x squared minus 4 is equal to 0, and x minus 5 is equal to 0. So x is equal to 5 for the second one. Add 4 to both sides. X squared is equal to 4. What should I do next? Square root. So what is x equal to? Plus or minus 2. So positive or negative 2. So my zeros would be 2, negative 2, and 5. Whatever your highest degree is, that gives you a hint on how many zeros you may have. Sometimes a 0 could be imaginary, so it's not always the case, but we wouldn't have more than 3 zeros. So because it's x to the third power, we're going to have 3 answers. Oh, multiplicity. So multiplicity is if you have multiples of your answer. Do I have any multiples here? Anything repeating? No. So they all have multiplicity of 1. One of your zeros could be imaginary, which would count in your total number of zeros. So you could have less than your highest degree. So we could have 2 zeros if one of them were imaginary, but you wouldn't have more than 3 zeros.
And you don't leave your imaginary as an F?
Depends on what it asks for. So if it was asking for real zeros, then you wouldn't put an imaginary. So multiplicity of 1, or you could say no multiplicity, because nothing repeats. Number 10, we have to find the slope and the y-intercept of the equations of the lines and sketch the lines. So to find the slope and the y-intercept, it'll help to put it in slope-intercept form, so y equals mx plus b. So we can rearrange our equation here. I'm going to start by subtracting the 16 to the other side and adding the 8x. So negative 4y is equal to 8x minus 16. And then divide everything by negative 4. So y is equal to negative 2x plus 4. So what's my slope? Negative 2. And what is my y-intercept? 4. And then to sketch the graph, always start with your y-intercept, so I would have a point at 4. And then to do the slope of negative 2, we go down 2 to the right one. Down 2 to the right one. So that would be my line. Grade 11. So we have to write the function in vertex form. So our vertex form is x minus h squared plus k. So if something says to write the function in vertex form, we are most likely going to have to complete the square. Or, actually, I think we did it another way. We just found the vertex. Does anybody remember the little formula that we need to use to find the vertex? Negative b over 2a. Just finding the vertex is actually going to be a lot easier than completing the square, so that's what I would suggest if you remember the formula. So negative b over 2a helps us find the x, or the h, the x coordinate of our vertex, which is the h, and then we plug it in to find the y. or k, as it is in our equation. So I have a, b, and c are coefficients. So negative b over 2a would be negative 16 over 2 times negative 4. So negative 16 over negative 8, which would be 2. So the h in my vertex is 2. We plug it in to find the k. So I have negative 4 times 2 squared plus 16 times 2 minus 3. So this would be negative 16 plus 32 minus 3. 16 minus 3, which is 13. So this is our h and k. So I'm going to plug that in. This, the negative b over 2a. So it's a times x minus h, so x minus 2 squared plus 13. What's my a? The a in the original, so it's just negative 4. So that is vertex form. So your vertex form is always going to be in this form. You don't have to FOIL it out. You don't have to expand it. If you FOIL it out, you would get standard form. For your answer, you have to find h and k and a and plug it in. So plug those in. All right, for 12, we're going to do the same thing. We want to find the vertex. So we're going to use the negative b over 2a. So here, we don't have to plug it into vertex form. We're just going to find the vertex. So just that point. So I have a, b, and c. So this would be negative 4 over 2 times negative 1. Negative 4 over negative 2, which would be positive 2. So that gives us the h in our vertex, or the x. How do I find the y? Plug it in. So I plug it into all the x's. So this would be negative 2 squared plus 4 times 2 plus 11. So this would be negative 4 plus 8 plus 11. So 4 plus 11, which is 15. So my vertex would be 2, 15. All right, we're going to do one more, 13. So you have to write the vertex form of the equation of the parabola that has the indicated vertex and passes through the given points. So our vertex form is y is equal to a times x minus h squared plus k. All right, last one. All right, do I have either my y, a, x, h, or k? Do I know anything? What do I know? H and k come from my vertex, and x and y come from my point. So I'm missing the a, but I can plug everything in to find what the a is. So I'm going to plug everything in. So I have y is equal to a times 1 minus 2 squared minus 8. So we're solving for a now. I need to figure out what my a is to plug in my a, h, and k. So I have 7 is equal to a times, I got to do my parentheses, so that would be negative 1 squared. What's negative 1 squared? 1. So that would be a times 1, which is just a, minus 8. And then what would I do next? Add 8 to the other side. So this would be 15 is equal to a. So we found our a. Now we just have to plug that in. So I have y is equal to 15 times x minus h, which is 2, squared minus 8. And that would be our vertex form. your vertex form, you always just leave the x and y in there. The x and y don't change. We only plug in our x and y to help us find the a.